Our next topic is going to be brought to us by Rich Merhige from Advanced Mechanical Enterprises, or AME Solutions. The title is Work Smarter, Not Harder, Reliability-Centered Maintenance. Anyone who's been to one of these yacht engineering seminars before is familiar with Rich. Most of you in the industry are familiar with Rich. Rich started in 1992. He founded Advanced Maintenance Engineering, and later in 2002, Advanced Mechanical Enterprises. He attended the State University of New York Maritime College, earned a bachelor's degree in marine engineering, continued his education in systems and ocean engineering at Virginia Polytechnic and George Washington Universities. He furthered his specialized training, earning a U.S. Coast Guard license as a second assistant engineer, steam and motor, unlimited horsepower, and a certification as a vibration analyst. Guided by his knowledge and expertise, AME is recognized as an external specialist for condition monitoring by the American Bureau of Shipping, or the ABS. Before starting his own company, Rich worked with such prominent organizations as the American Transport Lines, Westinghouse, David Taylor Naval Research Center, and Booz Allen and Hamilton as an engineer. His career saw him traveling throughout the United States and abroad, conducting sea trials, performing major equipment overhauls and installations. A foremost expert on vibration analysis, Rich Merhige.
Good morning, everybody. So, I was thinking, what makes a person become a marine engineer? And I think what I've read is that you become a marine engineer if you don't have the charisma to be an undertaker. So anyway, that's my joke to kick it off. Welcome everybody. I really appreciate you being here. I will do my best to keep this as interesting as possible, and I will have a lot of give you guys the opportunity to do any questions and answers and impart any wisdom I can to you. So with that, the title of my presentation is Work Smarter, Not Harder. And the idea of working smarter and not harder is that, I've seen boats go into the boat yard and they're going around in circles trying to find a vibration problem. And what I'm here to do is to, give you guys some pointers on what could be possibly causing that vibration and what we can do as vibration analysts to help you troubleshoot that. So condition monitoring is using technologies such as vibration analysis. We do a sea trial before a boat will go into a vessel go into a boat yard. And we'll come up with findings and give a specified work list on what needs to be addressed. Hey, we see an engine misfire. You've got a misalignment. You've got a worn out coupling. Your engine mounts are bad, or deteriorated, or they're out of balance. Those kinds of things. Exhaust system issues we can pick up on. So there's some new technologies that are out there. One of the things that's pretty exciting is this, there's this new technology we've just started using. It's called video motion amplification. And I'll go into that a little further. We're using that now. We're using high-speed video, and by slowing down the frames and amplifying the motion and actually putting a dot on the pixel, we can actually measure the vibration of something with a video, which is pretty cool technology. And of course, infrared, people, I'm sure you guys are all familiar with infrared analysis, and those cameras are so cheap now. You can buy the little attachment for your cell phone for $350 from FLIR. And then of course we have oil analysis, which everybody should be doing. Fluid analysis. You got your hydraulic oil, your coolants, and your engine oil, your gear oil. That should all be checked when you go to either sell or purchase a boat. You want to check your fluids. There's some of our hardworking technicians. You have to forgive me, I can't see the slides here. So, what we're doing is vibration analysis there. We're So we set up we'll walk around with a portable handheld analyzer. We'll measure at points on the engine and on the hull, and we can actually in the reduction gear, and from that we're able to get an idea of what's going on with the condition of the machinery. It provides advanced warning. You can see if there's, like, I picked up a broken tooth on a gearbox once. I mean, those are the kinds of things that you wouldn't normally see or hear. And also, you know, the advantage of doing this and using this technology is you're putting the energy and effort into work that actually needs to be done. You're not spinning your wheels. It's also a good QC to make sure the work was done properly. All right. There's a vessel in town called Tin Man's Pride that has our system on it. We work with a company out of Germany called Prüftechnik, and it's a permanent online vibration monitoring system. And you can actually pull this screen up. It's got a little dashboard that you can pull up on your cell phone and give you all the information on the vessel at that time. And it's pretty cost effective. And I think it's a good selling point for the vessel. And one of the things is that, you know, I mean, captains might not like this, but the owners do. It's you know, the owner of this particular vessel sits in his office up in New Jersey, and he could see what's going on with his boat at any time. Pretty cool stuff. So he gets all the trends. He sees the vibrations. He could, you know, if the vibration level triggers an alarm. He's got a vibration. They got vibration on the seatkeeper, so they can keep an eye on that. I mean, so it's kind of, you know, the boat is a valuable asset, and keeping monitoring on that, and being able to remote monitor through the internet is pretty cool. So with cellular modems and with VSATs, that technology makes it pretty easy to export this data. So you can see there, just gives a bit of a graphic of what systems are being monitored, and green, yellow, and red. So it's like a black box. I think it'll be eventually the insurance companies are going to catch on to this, and it might be something that the insurance companies will give you a discount on your insurance, and I can see it going that direction. I actually met with a big insurance company up in Manhattan about a month ago, and they're looking into this technology. What do they call it? It's the Industrial Internet of Things. That's coming. Everything's going on the internet. All right, remote continuous monitoring. This shows in Tin Man's Pride. There's the blue box. It's nothing exciting there, but it shows that, you know, the installation's pretty clean and neat, and it's attached to the aft engine room bulkhead. Picture on the right is turned sideways, but that's the red thing is it's called an accelerometer, and that's the sensor that we use to measure vibration signals. And this thing is continually recording data, and it's stored in there's quite a bit of memory in the hardware, and then it dumps the data whenever it comes into the modem. And then you see there's a engine mount turned sideways. Whole thing pitches. All right, there's a video of, this is the video motion amplification I was talking about, and it's from a company called RDI Technologies. We did this job about 2 weeks ago up in the Bering Straits in Alaska on a 200-foot fishing boat. Boat's 5 years old, and they've been having, it has a diesel electric propulsion system, so it uses, I don't know if people have heard of shuttle, but shuttle electric, so it's got 2 Z drives with shuttle inputs, using electric motors, using gen sets to drive those electric motors. And what was going on here was that the torsional coupling between the generator and the engine was continually failing. And I mean, this boat's operating in 30-foot seas and 70-mile-an-hour winds the week before, and the chief engineer can't afford to have this thing break down on him. So they were willing to pay whatever was necessary for us to get up there and troubleshoot this. So this is a video, this is going to show the video of the video motion amplification technology this is the latest thing that came out in the world of vibration analysis. And you can see, I think you'll be able to see what's going on here, which is the beauty of this technology. You can actually visually see what's going on. There goes that. Was that my video? Is it? Yeah, but where's the video of the actual motion amplification? Is it? It's in there? Okay. Yeah, this is just a video of the setup showing the screen. There it is. Okay. I don't know if you can see that. There you go. See it? The strut, that's the drive end of the engine. And what was happening is the thing was actually flexing, and where's the pointer? Ah, got it. All right, so what was happening is this is the bracket off the drive end by the flywheel. These are the supports for the electric, for the generator. And this was flexing to the point where it was cracking the welds in this corner. So the whole thing was twisting. And what it turned out to be was this arrangement and this support was weak. And we ended up making new brackets. And I was really surprised. Up in Dutch Harbor, Alaska, they had a water jet cutting table. They could do the fabrication. These guys were pretty well-equipped machine shop up in a very remote place. I was pretty impressed. So they made new brackets for the engine. We went in with our laser alignment system. This is a 2-bearing generator, so it has to be laser aligned. The shaft, the flywheel to the generator input has to be perfectly aligned. We aligned everything and it ran like a top. And they were extremely happy. We were the third company to troubleshoot that. All right, moving on to the infrared thermography. There's one of our engineers. This is on a cargo ship, and he's doing an inspection on the breakers and the switch gear. And you can see from that picture right there, there's a hot spot in one of the legs. This is the constant heating and contraction of the parts causes the fittings to come loose on the electrical connections. And if those things aren't snugged down over time, they'll just work themselves loose. And that's where you get increased resistance, increased heat. And this is the kind of thing that could eventually lead to a fire if you're not careful. So, this infrared technology is really cost effective and relatively easy to use. I mean, you're just looking through a camera. So, I mean, understanding the temperature rise and all that is more to it, but I don't want to oversimplify it, but you can see the hot spot. All right, and of course, fluid analysis. So you have, with fluid analysis, you're looking for, particulates in the oil. You're looking for, chemical content, water, and of course, they even have they use a spectrometry. I can't even say it. Spectrometry, where they'll put a microscope and actually look at the particles, and the particles in the oil. They can tell what the wear particles are, if it's a bearing, if it's a piece of a gear, all that. All right, this is just a little sample of. This was a vessel that was, it's a sport fish. It was coming down from on the intercoastal through North Carolina and Virginia. And what's that called? The swamp something? Dismal Swamp. And I guess, unfortunately, there was a large submerged railroad tie, which was, they didn't see it. They were cruising along. They were kind of in a high idle. They weren't really going that fast. But they hit this thing, and I guess the tie must have got in between the two props and really caused havoc. And they ended up with a tremendous amount of so they got a lot of damage. They went to a local yard in Virginia. They had the props pulled and the shafts and all that straightened, and they just continued to have vibration problems. They just couldn't seem to figure out what was going on. Just never stopped going away. This thing was, so, we went and did a vibration survey, and we found that there was, and we were the third repairer to get involved in this project. I mean, they had spent thousands of dollars trying to sort this out. And we were the third one in the line. And then, so we found that there was misalignment. We found that the engine mounts had actually gotten torn. The rubber elements inside were damaged. We also found that there was damage to the shafts themselves. They were twisted, and the keyways were damaged. And what was really interesting about this, and which is overlooked, and one of the things I want to highlight here, is the torsional coupling between the engine and the gear was actually bent. There's an aluminum ring that mounts to the flywheel, and then this coupling inserts into that aluminum ring. That's how the gear and the engine are connected. And there's the okay, so this is showing the alignment, and I wanted to show you that torsional coupling. There's the torsional coupling. And you can see here, so this is it's a silicon rubber element. It's made out of silicon rubber, and this is the aluminum ring that mounts to the flywheel. This was actually bent. These were bent, and it was distorted, so it was causing a vibration with every rotation. And this thing had broken apart at the teeth. It had cracked and separated. So this is a rubber element that's vulcanized, molded to that steel hub, and then this is bolted onto the gear. And then what you do is you buckle these things, connect these things together, and it fits inside the aluminum ring. These couplings need to be changed every 10 years, and they're overlooked all the time. I mean, it's constantly overlooked. You really this has to be, so every 10 years you should look at changing out the engine mounts and changing these couplings. And if you strike something, this needs to be part of the investigation, and it's quite often it's not. And that will cause all kinds of havoc. Going back to the alignment, so what happens when you hit a railroad tie? It can bend your struts. It can twist the strut. That's quite a bit of force, and it's really strange. I see boats hit bottom and nothing happens. I mean, they get away with it. I guess it depends on what you hit, how you hit it, how fast you were going. There's so many variables. It seems to be. And then, of course, the stiffness and the rigidity of your shaft line, if it can handle it, if it's meant to be flexible. Some of them are better absorbing those things than others. But in this case, this railroad tie, I guess it was a hard strike. It brought everything to a sudden stop. So there's a lot of inertia there. There's a lot of moving parts. The coupling it was the fusible link. If it wasn't for that, it might have bent the crankshaft. So those couplings are the fuse in the system for the torque. And you can see here that this is quite a bit of misalignment here. 174 thousandths low on the gear, and with the strut, this is so we use an optical bore scope. We shoot a target through the strut, a target through the stern tube, and we see what the position of the gear is relative to that straight line. In this case, both gears are 174 thousandths low. All right, and then some other things to think about when you're going into dry dock, not related to that other issue. How you block the hull is critical. Some of the marinas are really good at blocking. They keep the boats from not bending, and they're really careful about where they put the straps on a travel lift, or if you're using a synchro lift, when the diver sets the blocks underwater, when they lift the boat out of the water, they lift the weight off pretty evenly. I mean, all that stuff is really important, especially when you're getting into doing alignment work or running gear work. You want to make sure that the boat isn't hogged or sagged. And you got your, prop. That one took a pretty bad beating. And of course, this is a bearing that's been exposed to seawater. And, we pull all this stuff out, and we use an optical bore scope to do the alignment. And on some of the, on the bigger yachts, when you're starting getting above 60 meters, we'll start thinking about using laser alignment systems for the alignment. And rubber cutlass bearings are pretty tolerant, but like the oil babbited shaft lines are not as tolerant, so we'll use a laser alignment system to get a more precise alignment. And the advantage of that is it's also gives you documentation at the end of the day. Whereas optical, you're really relying more on the operator of the bore scope and his skill. So this picture here shows one of our guys with an optical bore scope, and I'm sure a lot of people in this room have seen this. Of course, cutlass bearings, bearing clearances should be checked. You want to check your shaft seals. You want to check the mount loads. It's very important that the mounts on the propulsion. So when you have a remote mounted gear, the gear's taking the thrust, or you may have a thrust bearing in the system. When you have a close coupled unit, the engine mounts on the close coupled unit are taking the thrust force. So it's important that the engine mounts are properly balanced and the weight is all evenly distributed. Otherwise, you get what's called soft foot, and the thing will vibrate. It's pretty obnoxious. You want to make sure check these couplings, like I was speaking with earlier, and of course hydraulic systems. You want to check for leaks. We've been using a luminescent fluid. We put a luminescent fluid in the tank. We'll circulate the oil, and then with a special, with a light, you'll be able to pick up special like a dark light. You'll be able to pick up the leaks with that. It's pretty good stuff. Check your rudders. You want to make sure your struts are well attached to the hull. There's no leaking of salt water through the bolts. And of course, everybody always neglects this. You want to make sure you exercise your valves periodically on a boat, especially a boat sitting in the water. If you don't exercise the valves, you get crust. Especially seacocks, they'll be crusted up with marine growth. And then your valves will start corroding and leaking, and it's a real pain in the neck. Any questions? None? Yes, sir.
Hang on a second.
What was the cost of repair on that 64-foot sport fishing boat?
It was 6 figures. That's why you got insurance.
I think the big takeaway that I get from your presentation, Rich, is that in this industry for a long time, it's been a very rudimentary sort of science. And what I hear is that we can try to fix things 2 and 3 times because we don't want to spend the money to bring in the experts. But at the end of the day, to bring in the experts and pay the price that needs to be paid is actually the cheaper alternative, because you get to identify all the different issues that may be the case. It may be a Vulcan coupling, and who thinks it's a Vulcan coupling? Who thinks it's a worn-out engine mount and you can't get rid of the vibration because we went through the props, we went through the struts, we went through the bearings, we went through the rudders,
right.
We went through everything. But there's a remaining
the old
vibration
saying,
or challenge.
Penny wise, pound foolish.
Exactly.
By the way, thank you for that plug. I appreciate it.
Oh, it's a fact. I mean, I'm not here to advertise, but the fact of the matter is, the inexpensive solution is not always the better one. It's often not.
Couldn't
the better
agree
one.
more. We see it all the time.
Absolutely. We have one more question from Jeff.
Hey, Rich. Thanks very much for the great presentation. I wanted to go back and talk a little bit more with you, see if you could elaborate some on the oil samples and the oil testing for condition-based monitoring. I didn't know if you guys did that in-house or you had a trusted laboratory. I was in a case about 6 years ago on a water jet boat, and we were trying to clean and replace the hydraulic fluid in the Kamewa power packs.
Sure.
And what I learned myself was that it almost requires surgical precision to capture that oil sample in order to deliver it to the lab, or else you'll never get, we could never get the contaminants down. You know, I used a face mask and rubber gloves, and we broke the seal on the sample vial, and we put the oil in there, and we'd send it in, and it never met. We could never get it to meet, no matter how often we flushed it, no matter how many times we changed the fluids. We still had too much particulate in there. Have you ever experienced anything like that, trying to get it, so you had a good result, a positive result on the
It's a good,
oil?
thank you for that question. It's a great question, and it brings to light some things that we can discuss here. First of all, the flush, the flushing the system. We have personally found we use, when we flush hydraulic systems, we use a flush, a very hot water flush, hot water detergent. We don't think, and this is what the U.S. military does when they have hydraulic system flush requirement. It's a hot water flush, hot water with detergent. Because the problem is, if you try to flush it with oil, it won't chase the contaminants out of the system, and you'll be chasing your tail. I've seen it many times. So if a hydraulic system gets contaminated, the best way we found to flush it is with hot water and detergent. And there's this company in town that specializes in that. We subcontract for that work. And then your point about where you get the sample and how you take the sample is very good. You really, when you take an oil sample, you really got to get it from a place where there's flow of the oil through, and you've got to use a very clean special sampling pump to pull the sample out of, and you want to make sure you get the sample at a valid location. You don't want to take a sample out of the filter, for example. I mean, you're going to be finding the contaminants there. You don't want to do that. You want to get it out of a spot where it's getting good flow.
Thank you, Rich. Steve?
Just to add, what was really neat about that opportunity was, after about 3 weeks of trying and failing, I opened a top off of a brand new container of hydraulic oil and poured it into the sample in the saloon on the yacht, and the results came back where it failed also. So the new stuff was too dirty to put in the boat.
That's interesting. Yeah. So you did send a clean sample along with because that's what you got to do, because the lab will need both. Okay.
Yeah, Rich, what has been your experience lately with the oil bath torque tube drive systems that are now becoming pretty predominant in a lot of boat installations? Have you found that the consistency of alignment is better from the standard, as we know, shaft drive systems? If you could give me a little feedback on that. Sure.
From what we've seen, those systems, there's a couple manufacturers out there. The advantages of that system is that you don't, that your shafting isn't going to be subject to corrosion and marine growth, and you'll also get a lot of hydrodynamic efficiencies by having an enclosed shaft not generating the turbulence. So there's a lot of benefits to that in performance. You have the ones we've seen have been, actually, I'm kind of surprised. They're a lot more robust than I thought they would be. I know a lot of the sport fish guys are very interested in that type of shaft line, because I think they feel it helps them catch the fish. But as far as the alignment, it actually makes the alignment a little easier, because it fits in and it's already aligned, right? So then they'll use either a CV joint shaft or a cardan shaft from the forward end of that to the gearbox, or to a thrust bearing, and it's a good system. I see where they work pretty well. Downside is, you get a fishing line wrapped and you tear up the seal. That can be a negative.
But you don't have the opportunity to target that shaft because it's really encapsulated. You can only study the input and the output end of it, I guess. Is that correct?
That's correct. Yeah. See, like if they were to have a strike you'd have to, pull the prop off and dial it at the hub and see what you see there. And with vibration analysis, we can pick up if typically those things use roller bearings, and we can pick up the vibration from the bearing frequencies in our analysis.
Okay. Military, I think, has been using that, and the company that's doing a lot of that is right up in Stewart. So there's a good laboratory up there for you to be able to get access to, I would think.
Sure. Thank you.
All right, Rich, thank you very much. That's a great presentation. Brings to mind a lot of great questions. Thank you.
Thank you.